Welcome to Engineering Max. In this video, we are going to cover few basic definitions of probability theory with the few problems and formulas. Now let's start with the definition. What is a random variable? In an experiment, if the real value is associated with every outcome, then it is called as what? A random variable, or we can also call it as stochastic variable. So the basic, no need to remember the definition. The thing is, here the whatever when we solve the problem will get output, right? The output will be associated with a random variable. So that's it. That will be the definition of random variable. So random variable is denoted by x, y, z. You can take any values. It may be a, b, c, or it may be whatever. You can take any real values. Next, moving on to next topic, that is what is the discrete and continuous random variable. Discrete is the one the random variable value should be finite. We can see the definition, that is if a random variable takes finite or countably infinite number of values, then it is called as what? Discrete random variable. So the value whatever we random variable takes, that should be what? Finite x value, y value, z value, it should be what? Finite. Then moving on to what is continuous random variable. The opposite of, or we can say that continuous random variable should take infinite number. The random variable value should take infinite number. So that will be the definition of continuous random variable. Next, moving on to next topic, that is discrete probability distribution. What is the discrete probability distribution? We'll see the discrete probability distribution value, whatever we assign the real value, that should be satisfy these two conditions, that is p of x value should be greater than or equal to 0 and sum of p of x is equals to 1. Here the remember one thing is discrete probability. If the solution is a discrete probability, then it should satisfy the two conditions, that is p of x should be greater than 0 and sum of p of x is equal to 1. Next, the set of value, that is xi or p of xi, is called as what? Discrete probability distribution of discrete random variable x. The whatever we are going to take random variable, that should be the value of what? Discrete random variable. Next, the function f of x is called as what? Probability density function, or we can also call it as probability mass function. These are the formulas you must remember for solving the problem. First formula is the distribution function f of x is given by f of x is equals to p of x is less than or equal to x, that will be equal to summation of x I is equals to 1, p of x is p of xi, where x is an integer. For finding the mean of a discrete probability, distribution, it is given by mean of that is mean is represented by mu, or we can also find mean by, we can also call the mean as expectation, that is equals to summation of xi p of xi. Similarly, for finding the variance, we have formula v is equals to summation of xi minus mu whole to the power square p of xi, or we can also find mean by using this formula. For finding standard deviation, we have formula called standard deviation is equals to root of v, that is variance of root of variance, will get standard deviation. So this is all about some basic definition of probability theory. Now moving on to the problem. First problem is a coin is tossed twice. A random variable x is the number of heads turning up. Then what they are telling, find the discrete probability distribution, and also they are telling us to find mean and variance. For that we'll write first whatever given and what we should find. So the given x they taken as number of heads turning, and what they are telling us to find, we should find the discrete probability distribution. We should find discrete probability distribution, question mark. And also they are telling us to find mean question mark. Variance also they are telling us to find. Now according to given definition or given question, the coin is tossed. When coin is tossed twice, what are the possibilities? So when coin is tossed twice, what are the probability we will get? That is sample space. Sample space is equals to, it may be head, it may be head tail, it may be tail head, it may be tail tail. These are the possibilities, right? We will get when we toss a coin twice. So first, now what we should prove that it is, or we have to find the discrete probability distribution. For that, what I will take, p of x, that is random variable value x is equals to 0. So the probability of turning head is 0. So that is we got 1. When we toss a coin twice, then we'll get tail. That will be the one possibility, right? So x is equals to 1. There is no head at all. So that is given by, out of 4 possibilities, we can write 1 divided by 4. That is tail. Similarly, if p of x is equals to 1, I will take p of x is equals to 1. So the probability turning head, here there is 2 probability, right? Here 1 probability, here also turning head 1 time, and here also turning head 1 time. So can I take 1 divided by 4 plus 1 divided by 4, then take LCM as 4, then 1 plus 1 is 2, then what will get? 2 1s are 2 2s are, you will get 1 by 2. Similarly, if I take x is equals to 2, then the probability of turning head, that is 2. That we can write 1 divided by 4. 1 divided by 4. So out of 4 possibilities, there will be 1 which turns 2 heads, which contains x value should be 2. That is equals to 1 by 2. That is head. Now what they are told to find the discrete probability distribution. For discrete probability distribution, we have condition, right? That is p of x I should be greater than or equal to 0, and p of summation of p of xi should be equal to 1. So according to that, here we have taken x is equals to 0, right? So first condition is proved. For next condition, we will check whether it is equal to 1 or not. For that, I will take first p of x is equals to 0 value, that is 1 by 4 plus, then p of x is equals to what? 1 by 2, that is 1 by 2 plus p of x is equals to 2, that is 1 by 4 equal to 1. Is that what you will get? First I will combine these two, then what you will get? 2 divided by 4 plus 1 by 2. Next 2 1s are 2 1s are. 2 2s. Then you will get 1 by 2 plus 1 by 2. That will be equal to what? That is 2 by 2. 2 ones are 2 ones. You will get 1. So we found discrete. We found discrete probability distribution. Now we have to find mean and variance. I'm going to write it in a table, that is xi is equals to and p of xi. X is equals to 0, that is 1 by 4. X is equals to 1, that is 1 by 2. And x is equals to 2 is 1 by 4. So this is what we got right in while finding the discrete probability distribution. So that I'm going to write it in table. So this is our table. Now we are going to find the mean. We know that mean formula. What is mean formula? Mean formula is equal to summation of xi, p of xi. Now what is summation? We should add all the values. That is, what is x value first is 0. So 0 into what is p of xy value? 1 divided by 4 plus next 1 into 1 divided by 2 plus 2 into 1 divided by 4. Now what will be the value? Here it will be 0 plus 1 into 1 divided by 2 plus, can I cancel here? 2 1s are 2 2s are. Then what will get? 1 by 2. That will be equals to, here LCM is 2, so we will get 2. So mean will be, the answer is 1. Now they also told us to find variance. What is the variance formula? Variance, that is V equal to summation of xi mu whole square into p of xi. Now what is xi? First one is 0. So 0 minus what is mean? We got already, that is 1 square. What is p of xi value? That is 1 by 4, first value, plus second is 1. So 1 minus 1 whole square into what is the value of p of xi? That is 1 by 2. Same. Next x value is 2. So 2 minus 1 whole square into 1 by 4. Now what we will get here? Minus 1 whole square is 1. So 1 into 1 divided by 4, right, as it is. Then minus 1 plus 1 get 0. So it will be the 0. Next to 2 minus 1, that is 1. 1 into 1 divided by 4. Now what we will get? Can I write 1 by 4 plus 1 by 4? Yes. Next 4 will be the LCM. Then 1 plus 1 2. Then 2 1s 2 2s. So 1 divided by 2 will be the variance answer. This completes your problem. If you have any doubts, let me in the comment section.